Okay guys, today we are going to understand the concept of Boolean logic. To understand Boolean logic, it's important that you deal with three terms very clearly. What are the terms? So let's look at the terms. The first word you need to know is logic gate. The second term you need to understand is logic circuit. And the next or the most important here is the truth table. Now let's elaborate these as we get into the details. Okay, so I'm changing the color so we know what to do. So what is logic gate? Logic gate is simply takes the binary input and produces the binary output. Logic circuit. If you use several logic gates, the combination is going to produce a logic circuit. So let's say the combination of logic gates. Now, truth table is an important thing because if you want to check the output from a logic gate or a logic circuit, you're going to use truth table. It's also called as the trace table. So what does this trace table do? It checks the output from a logic gate or a logic circuit, which is a combination of logic gates, of course. So if you look at this, the most important word that you have come across is binary. So let's understand what is binary. So the word binary, it has got two values. The binary is 2. What are the two values? The two values are 0 and 1. Let's try to relate these values 0s and 1 in terms of logic gate. So I'm going to make a little table so that whatever form you're going to use these 0s and 1s, it's clear as we understand the details. So we are going to deal with 0 and 1. Now, when you talk about the logic gate, 1 can be true and 0 is going to be false. 1 can be on, 0 is going to be off. 1 can also be high and 0 is going to be low. So when we are dealing with logic gates, we'll use either 0 ones or either of the two combinations. So again, just to put it together, you're going to use the two values. Either it's going to be 0, 1, false, true, off, on, low, high. Okay, now we are going to understand how to deal with the truth tables. Because once you understand the truth table, you'll be able to have the inputs and trace the outputs for the logic gate, or if a combination of a logic gate, that's called as a logic circuit. The word is table here. To create the table, we need to start with rows and columns. So let's decide on the rows and columns. We are going to deal with 2, 3, or a maximum of 4 variables. That's enough to understand the basic combination of the logic gates. These variables can be represented by A, B, C, D, or W, X, Y, and Z. One thing we need to remember here is they're all in uppercase. So once we are decided with this, we need to figure out the number of rows and columns. So number of rows. Number of rows is equal to 2 to the power n, where n is number of variables. Let's say we are taking 2 variables, then the number of rows is going to be 2 to the power 2, which is equal to 4 rows. Now let's decide on number of columns. Number of columns is very straightforward. It's equal to number of variables. So if you have got 2 variables, is going to be 2 columns. So it's straightforward. Now let's try and see how the combination is going to work for us. So the job is here to understand the inputs for a truth table. We are taking 2 variables, which means rows is equal to 2 to the power n, which is 2 here, 4, and the columns is equal to number of variables, which is 2 in this case. So let's get started. So let's make a table that has got 2 columns and 4 rows. Now the question arises, how do I input the values? So let me just add one more row on the top to represent the variables. So this is going to be A and this is B. This is one trick. Whenever you are writing the variables, always start from left hand side and goes to the right hand side. That's for the variables. For the values, you start from the right side and go to the left side. So we start from 2 to the power 0, which is equal to 1. Increase the power 2 to the power 1, which is equal to 2. Now what does this mean? This 1, I'll just highlight this. This 1 means one time repetition of 0 and 1. One time repetition of the binary values 0 and 1. So let's go. You need to make sure you have filled all the rows. So 0, 1, 0, 1. Following the same trick, it's 2 times, that means 2 times 0 and 2 times 1. I hope this is clear. Now let's try it with the 3 variables. So let's go. So 3 variables. Let's decide upon the number of rows. Rows is equal to 2 to the power 3, which is equal to 8. So we have got 8 rows. Columns is equal to number of variables, which is equal to 3. So it's going to be 3 columns. Okay, now let's make the structure of the truth table. So we need to have 3 columns, 1, 2, and 3. We need 8 rows. The first we'll leave for the variables, and then we have to make 8. 1, 2, 3, 4, 5, 6, 7, and 8. As mentioned before, we need to start writing the variables which are represented by A, B, C here. We need to start writing from the left hand side. So this becomes A, this becomes B and C. Now we need to see how many times you're going to repeat the combination of zeros and 1. Always start from 2 to the power 0, which is 1. This is 2 to the power 1, which is 2. And this is 2 to the power 2, which means 4. So let's give it a try. So 2 to the power 0 is 1. That means it's going to be one time repetition. 0, 1, 0, 1, 0, 1, 0, 1. It's 2 time repetition. That means 2 times. 0, 0, 1, 1, 0, 0, 1, 1. It's 4 times. So 4 zeros. 1, 2, 3, 4 and 4 ones. Remember, again, we need to make sure we fill all the 8 rows. But the combination goes according to the calculation we have made here, which is 2 to the power 0. It's one time repetition. So 0, 1. 2 times repetitions. 2 times 0, 2 times 1, 4 times repetition, 4 zeros and 4 ones, and it's always worth starting with 0 as the counting goes zeros and ones. So this is when you're dealing with the 3 variables. Let's try with the 4 variables. So we are taking 4 variables. I'm sure by now you are expert in deciding the number of rows. So number of rows is equal to 2 to the power 4, which means 16 rows. Yeah, you're right. 16 rows, and the columns is equal to number of variables, which is 4 in this case. So 4 columns. So 4 columns and 16 rows. Let's make the structure. It's going to be taking a little extra space. Okay, so let's make the 4 columns. 1, 2, 3 and 4. We'll leave the first for the variables and then we'll make 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'll have to add few more. 14, 15 and 16. Okay, now this means we are going to start again. It's A, B, C and D. Start from the right hand side with the 2 to the power 0, which is 2 to the power 0 is equal to 1. 2 to the power 1 is equal to 2. Keep increasing. 2 to the power 2, the power, if you see, it keeps increasing. 2 to the power 2, which is 4, and then we have got 2 to the power 3, which is equal to 8. So basically, if you see, the columns is going to be starting from, this is the trick, columns start from right to left. Using 2 to the power 0 and so on. So it will be something like 2 to the power 0, 2 to the power 1, 2 to the power 2, and it goes in this way until it is 2 to the power n minus 1. So this is the logic here. So now let's fill the values. I'll take a different color. It's one time repetition. 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. This is 2 times. So it's going to be 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. This is 4 times. So 4 times 0. 1, 2, 3 and 4. 1, 2, 3, 4. 0, 0, 0, 0, 1, 1, 1 and 1. This is 8 times. So 8 times 0. 2, 3, 4, 5, 6, 7 and 8. 1, 2, 3, 4, 5, 6, 7 and 8. So this gives you the basic combination of zeros and 1 in terms of input values for a truth table. Now we'll look into how these apply to the logic gates. Okay, now let's continue and look into the logic gates, and then we are going to see how we are going to express these logic gates using the logic expression. So let me start. First, we are going to look into the logic gates. There are 6 basic logic gates. which we are going to use to create logic circuits. So what are these 6 logic gates? And, or, not, and, which is also pronounced as NAND, not or, and XOR, which is exclusive OR. So let me put the details for reference. This is also called as exclusive OR. This is also called as not OR, and this is also called as not AND. If you pay close attention, you'll see that all these gates are written using the uppercase. So that's one thing we need to remember. To understand these 6 logic gates, we are going to look into different things. So we'll learn about the symbol. We'll learn how to trace these using different variables through the truth table. And we are going to learn how to write the expressions. Each logic expression can be written using 2 different formats: the logic notation or the Boolean algebra. Now, what is the difference between the two? Let's understand. Logic notation uses the same gates representation, that is AND, OR, NOT, NAND, NOR, exclusive OR. However, the Boolean algebra has got a bit of relation with math. And the dot represents the AND gate, plus represents the OR gate, bar, this is a bar on the alphabet, a bar above the letter represents the NOT. Now we are going to learn the functions of these 6 logic gates. So we are going to use one gate at a time, and we'll look into the symbol, truth table, and expression. So the first gate I'm going to use is AND gate. Remember, you have to write all in caps or uppercase. So AND gate. So the first thing is, what is the symbol? Let's use 2 variables, A and B. Okay, so the symbol is very simple. Have 2 inputs. What are the 2 inputs? A and B. 2 straight lines, and again 2 parallel lines. And to join these, there's a little curve, and then you get the output X. So this is always the AND gate, and you could just write it in between to ensure you know it perfectly. Now this is the symbol. Let's make a truth table. Since we already have learned how many rows and columns would be there for the 2 variables, so we are very clear. Number of rows is equal to 2 to the power n. In this case, it's 2 to the power 2. That means 4. And columns, which is equal to the number of variables, remains 2. So now we have got this decided. So let's go. One, 2, 3, and 4. We are going to add 1 extra column to see the output, and then 1 extra row to have the variables as in terms of input. A, B, and X is the output. So let's start. Alternate 0, 1, 0, 1, because it's 2 to the power 0, which means 1 time repetition, and this is 2 to the power 1, which means 2 time repetitions for the input. 0, 0, 1, 1. Now when you're using the AND, 0, 0 will give you 0, it gives you 0, it gives you 0, and it gives you 1. Look at the logic. It's basic multiplication. 0 times 0 is 0, 0 times 1 is 0, 1 times 0 is 0, 1 times 1 is 1. Now we are going to look into the expressions. How do you write these? So, the expression first is the logic notation. You have to write it very clearly using uppercase A and B is equal to X. And then if you write the Boolean algebra, it's written as with a dot. So Boolean algebra A dot. This and is replaced by the dot, and this gives you the output X. So if you look into the description, what is the description for this AND gate? This is the most important thing. The description says the output, which is represented by X, the output X is 1 if the input, if all the inputs, let's say if all the inputs are 1. This is something very important to remember. Wherever you have got all the inputs as 1, which also means all the inputs are true, then only the output is going to be true. So this is all about AND gate. Now let's continue with the next. The next gate we are going to consider is the OR gate, and we are going to use two variables all the time to learn more about these basic gates. So two variables. First and very important thing is we are going to look into the symbol. How to draw this logic gate. So we are taking two inputs A and B. Two straight lines, and this time it's going to be a little curve. Look at the symbol. It's a little curve, and then it gives you the output as X. So this is the OR gate symbol. Now the next is we are going to use the truth table. The number of rows for 2 is 4. I'm sure by now you have got this learned very clearly. So, and the columns are 2 because the number of variables are 2. So let's make a table. I'm going to include the extra rows and columns as well here. The first row is for the variables, inputs and the output. The last is for the output. So we need 2 beyond this, 1, 2, 3 and 4, and 2 columns. So this is going to be A, this is B and X, which is the output. So this is the first column, 0, 1, 0, 1, 0, 0, 1, 1. This is going to remain the same whenever you're going to have 2 variables as the input. Now look at the output. This is going to be 0, 1, 0, 1, 1 and 1. Now what does this mean? This simply means even if one of the inputs is 1, you get 1. In another language, you would say if either of the inputs is true, the output is true. Also, if all the inputs are 1, it's going to be 1, or all the inputs are true, the output is going to be true. Now let's look into the detailed expressions. The two expressions we are going to talk about. First is the logic notation. The logic notation has to be written using the gate itself. So in this case, it becomes A or B. Always remember to use the uppercase when you are using the logic notation. For the Boolean algebra, we are going to replace the OR with a plus sign. So it becomes A plus B. So what is the description or the understanding of this OR gate? Let's make a note of this. The output, which is always represented by X, the output X is 1. The output X is true if either of the inputs or all the inputs are 1. I hope this makes it clear for the OR gate. Continuing with the logic gates, the basic logic gates, we have completed the AND gate, OR gate. The next is the NOT gate. Talking about the NOT gate, it doesn't have its own importance individually, but along with other gates, it works in combination. So let's have a look at the basics of NOT gate. The first important thing we are going to understand here is the symbol. So how does the NOT gate look like? So it's very straightforward, a straight line, a little bit of triangular shape, and then a knot that represents the opposite. So this is how it looks like. So if we have got an input A, the output X is over here. The most important thing you got to remember is it works with a single gate, and as I did mention, it works in combination with other gates. Let's quickly have a look at the truth table. We are going to use a single variable as A. So if A is the single variable, we have got the two values 0 and 1. The output X is going to be exactly opposite, and it's going to be 1 or 0. So this is the truth table for the NOT gate. Now let's have a look at the expression. The expression, as we have learned the logic notation and Boolean algebra, let's go one at a time. So logic notation would be written as X is equal to not. You have to actually write the word not and A. So it's opposite of A. That's how you need to remember. And talking about the Boolean algebra, X is equal to A, the variable with the bar on the top. That's how it's written. So this bar on the top represents the not of the variable. So it's a NOT gate. Now let's look at the description. If you closely analyze the values, if A is 0, the output is 1, A is 1, the output is 0. So logically, if you look at it, it's the opposite. Not. It's going to be opposite. So it simply means the output X is 1 if the input value is 0. So for your own understanding, you could remember that it's going to be the opposite. So whatever the input value is, opposite of that. We'll look into the NOT gate in combination with other gates, and let's wait until then. NAND gate. It's also known as the NOT AND gate. So you'll see when we are looking into the truth table, which is going to be tracing the output of the two input variables A and B, how it becomes the NOT AND. So let's start. First, we are going to look into the symbol. So to start with the symbol, and we are going to use two variables. Other than the NOT gate, all the time you need two or more variables. So I'm just going to write it over here so we do not have any confusion. So two variables we are going to use. For now, I have been using AB. You could also use other variables W, X, Y, and so on. So let's go with AB. So there are two inputs. Let's make the AND. I hope you remember two parallel lines, and then they're joined with a curve. To make sure it's a NAND gate, it's a combination of AND with NOT. To use the NOT gate here, we just need to add the circle over here, and this is the output as X. So just to put it together, there are two inputs AB, the symbol of the AND gate, but added with a circle gives you the NAND gate, which is the NOT AND gate. Now let's have a look at the truth table. We are going to have the truth table created in the elaborate manner so that you can have a understanding of AND and how it becomes the NAND gate. Two variables, so the rows are 2 to the power n, which is 2 to the power 2, in this case 4, and the columns remains equal to the number of variables, which is 2. So let's get started over here. We'll add the extra columns as we need them. So for now, I'm just taking the enough number of rows. We need to have one extra row to put the variables together. So this is A and this is B. Let's put the inputs first. 0, 1, 0, 1, 0, 0, 1, 1. To start with, I'm going to write A and B. If you remember, A and B gives you 1 only when both the inputs are 1. And if you remember the Boolean algebra, it's multiplication. Now, we need to find the output X, which is the opposite of A and B. That means not of A and B. This is what we are interested in. It's not. Not means opposite of this. So it's 0, it becomes 1. 0 becomes 1, 0 becomes 1, and 1 becomes 0. This is the output for NAND gate. So now to put it together, let's have a look at the expression. The logic notation, how do we write this? X is equal to A. We are going to use the same name as given on the top, NAND. B. The Boolean algebra. X is equal to, if you remember, the AND gate, we are going to use the dot sign, the multiplication A dot B and the NOT. This is how it's read, A NAND B. Let's put the description together. The output X is 1 if either of the inputs A, B or both are 0. It's exactly opposite of the AND gate. So we are interested in the zeros. So let's have a look at it again to confirm. It's both are zeros, the output is 1. One of the two is 0, the output is 1. One of the two is 0, the output is 1. Both are 1 and then it becomes 0. With the fifth gate, we are on to the NOR gate. And to use the details or study the details about the NOR gate, we are again going to use two variables A, B. You could also use any alphabet to represent the variables, but the standard way is using A, B, C, D or W, X, Y, Z as mentioned before. So let's look into the symbol first. To draw the symbol, you need the two inputs A, B. And if you remember, the OR gate is a curve. To make it not OR, you need to add the not sign over here, and here is the output X. Now we are going to look into the truth table. So since we have got the number of rows is equal to 4, I hope by now you remember how this 4 comes, and the columns is equal to 2. So let's make the truth table. We'll have 4 rows, 1, 2, 3 and 4 rows, and the topmost for the variables. We are going to go one at a time. So let's put the input values first. A, B, 0, 1, 0, 1, 0, 0, 1, 1. First, we are going to find out the input values for A or B. If either of the two is 1, it becomes 1. So both are 0, 0, 1, 1 and 1. Now, to get the NOR, let's complete the table. So X is equal to A NOR B has to be the opposite of this. So it becomes 1, 0, 0 and 0. Let's look into the expressions. The logic notation. It uses the standard symbol, which is NOR in this case. So X is equal to A NOR. Again, emphasize NOR in capital. A NOR B. The Boolean algebra. X is equal to. Now we need to remember the OR is represented by the plus sign. So A plus B and NOT. So this is how it works. A plus B with the NOT sign on the top. So how does the description look like? The description is for the purpose of remembering if you have got some quick trace tables to be created, or if you're dealing with some multiple questions, it really helps you to recall the inputs and the X output, because then you don't have to go into the detail and do the trace table completely. So here the output X is equal to 1 if both or all inputs are 0. Last and very important logic gate is the XOR gate, and I do hope you remember it's also called as the exclusive gate. We are going to make this exclusive gate using the two variables A and B. So first we are going to look at the symbol. It's a little bit different from what we have been looking at. So taking the two variables A and B, this one curve that's crossing the two lines, it's on the two lines, and then the normal curve as we use for the OR gate. And this is the output X. Just to emphasize, the first curve is crossing the two lines. It's overlapping the two lines. Now let's have a look at the truth table. The truth table is very straightforward in this case. Let's use the two variables, 4 rows, 1, 2, 3, and 4. A, B, 0, 1, 0, 1, 0, 0, 1, 1. Now X is equal to A XOR XOR. You can pronounce it either way. It's also called a XOR or XOR B. Is this is very simple rule. If both the inputs are same, the output is 0, else it's 1. I repeat, if both the inputs are same, the output is 0, else it's 1. Now let's have a look at the expressions. Logic notation. X is equal to A exclusive OR B, the Boolean algebra. Now this is going to be a little bit different from rest what we have seen until now. X is equal to A dot B complement plus A complement dot B. Look at the expression carefully. For the first time, B is complement, the next is A is complement. It's multiplication, it's addition. We will get this proved in a minute. So let's have a look at the description. As I did mention before, the output X is equal to 1 if both the inputs A, B are different. In other words, if inputs are same, output is 0. So if inputs are same, the output is 0. 0, 1 gives you 1, 1, 0 gives you 1. Even if it is 1, 1, it will give you 0. I'm going to quickly help you prove this Boolean algebra as well. So let's have a look at this. So let's get started. We'll take the two variables A, B. Irrespective of how many combinations we have, we'll always have only 4 rows. 2, 3, and 4. So this is 0, 1, 0, 1, 0, 0, 1, 1. Now let's take the first part of it, A dot B. So B has to be complement. Complement means opposite, B not. So opposite of this. So it's going to be 1, 0, 1 and 0. Now let's get the expression. I'll use a different color so that it's clear. Let me use red for this purpose. So I'm going to use A dot B complement. So A dot B complement, it's multiplication. So 0, 0, 1 and 1, 0 is 0. I'll go back to my original color. Now let's do the next. A complement dot B. So we need the not of A. So it's 1, 1, 0, 0. Let's go back to our color. We're going to use red and let's see. It's A complement dot B. So A complement is here multiplied by with B. So it's 0, 1, 0, 0. Now let's go back to the black and get the output. What is the output? X is equal to A dot B complement plus A complement dot B. It becomes a little bigger. I'll show you how to put this together. So let's go back to the output and this plus this, we are going to add the 2. So it's 0 plus 0, 0. It's 1, 1 and 0, which is the outcome of as we had seen over here. So if both the inputs are same, the output is 0 here, irrespective of whether the inputs are 0, 0 or 1, 1.